Hello and welcome to the NPTEL MOOCs course on Foundation for Virtual and Augmented Reality Systems. We are currently discussing aspects of system design, and there we have already covered few topics and we are going to cover few more in this part of the lecture. So, essentially we are talking about how to design immersive experience, and in that context we have already talked about interaction techniques and its importance. We have covered one interaction technique, that is object interaction. So, if you can recollect, there are different types of interactions that we encounter in an immersive experience. Broadly, they are of three types: object interaction, navigation and system control, out of which we have covered object interaction, which includes selection and manipulation interaction. We are going to continue our discussion on interaction techniques in this part of the lecture as well, where we will be covering the other components of interaction or other types of interactions. Now, what are the interaction types? Just a quick recap: we have object interaction, then navigation, and finally interaction for system control, out of which object interaction is already taken care of in the previous part of the lecture. Remaining are navigation and system control. Interaction for system control, we are going to cover these two, the remaining types of interactions in this lecture. So, what are the different navigation techniques that are typically used in any VR setting or immersive setting? Let us have a look at it. Now, when we talk of navigation, what is the goal of navigation? Goal is to move the user from one point to another in the virtual world. That means change of user field of view or viewpoint, I would say change of user's viewpoint. Now, there are actually two parts in any such movement. One is the travel part and the other is called wayfinding part. Now, the travel part is also known as the locomotion, and the corresponding techniques that are used to let the user travel in a virtual world from one place to another is called locomotion techniques, or alternatively the travel techniques. Now, travel is the motor component of the navigation, that is the actual movement. When we actually move our legs or limbs to move from one point to another, that is the motor component of movement, that is we generally are referring to as the travel or locomotion part of navigation. So, essentially it refers to the movement between two locations, between from one point to another. Now, there are different techniques employed to let the user perceive that a travel has taken place. The travel can be done in different ways. One is exploration. It means that there is no explicit goal to reach. I mean, there is no specific point where the user wants to reach. The user instead just wants to move around, to see things, to learn things, to explore things. So, that is the exploration type of travel. Then we have search, searching for specified target location or moving to a specified target location. So, user now, instead of exploration, user now wants to move to a specific location, that comes under search type of travel. Third technique is maneuvering. It essentially refers to short, precise movements changing the point of view or the viewpoint. So, when we are doing travel from one point to another, either we can do the traveling at one go, or we can travel as a combination of smaller, short, specific, focused travels. That means, a path is broken down into small segments, and travel between each segment we are performing, so that at the end we reach to the destination. So, this type of movement where the overall movement comprises of short, precise, smaller movements, that is called maneuvering. So, we can have different ways to travel from one point to another. Now, these travelling approaches, these travelling types can be accomplished using 4 broad types of locomotion techniques. We can have locomotion based on walking, that is walking based locomotion, then steering based locomotion, then selection based locomotion, and finally manipulation based locomotion. Remember, in our earlier part of the discussion we said that the object interaction and navigation are different in the sense that in object interaction typically manipulation of object is involved, whereas in navigation that is not generally the case. Object manipulation may not be involved. That is true for the first 3 type of locomotion techniques. However, in the last technique we do navigation by manipulating certain things that we will discuss at the appropriate time. So, manipulation is not entirely avoided while implementing travel techniques in an immersive setting. However, mostly navigation involves non-manipulation of objects. Now, let us try to understand each of these techniques one by one. We will start by the first technique, that is walking based locomotion. As the name suggests, walking based locomotion refers to travelling in the virtual world by physically walking in the physical world or the real world. So, some sort of walking or some sort of movement, physical movement is involved for corresponding virtual movement in the virtual world. Now, this type of locomotion can further be divided into several categories, broadly of 3 categories. One is full gait technique, partial gait techniques and gait negation techniques. So, these 3 are the broad categories of walking based locomotion techniques: full gait, partial gait and gait negation. What happens in full gait techniques? That actually involves real walking. So, the user actually walks in the real world and that walk gets translated to the virtual walk in the virtual environment, in the immersive environment. Obviously, this is the most natural way to travel. However, as we have seen earlier, giving a completely free form of walking is not practical or possible for virtual navigation. Instead, the walking is restricted within a specified limit in the physical space, which then gets translated to any amount of movement in the infinite, potentially infinite virtual space. So, of course, there is a mismatch, although this provides more natural form of interaction for navigation as compared to the other techniques. Then comes the second technique, that is partial gait technique. Unlike the previous one, full gait technique, here partial gait refers to the fact that the user walks, but walks in a place. That means the user does not actually change the position as shown in this figure here. As you can see in this animated figure, the user is walking, but in the single place. It is not actually moving forward, backward, left, right. That is partial gait technique. Now, implementation of these type of techniques may involve walking interfaces, active walking interfaces such as pressure mats, pressure sensors, and or interfaces with pressure sensors and so on. So that depending on the walking behavior, although it may be in a single place, but depending on the behavior of walking in that single place, the pattern can be mapped to different types of walking in the virtual space. So, partial gate techniques require some sort of specialized devices in addition to other immersive hardware for providing input. Now, in case of gate negation technique, even more specialized setup is required, because in such technique the user's lateral movements are cancelled due to the specified or specialized setup used, keeping his physical position fixed. So, although the user may be moving in multiple directions, but lateral movements in the movement in that movement pattern gets negated, gets cancelled because of the specialized setup used, and the user or the system maps that movement to specialized to or specific type of virtual movement. So, user may be walking naturally. However, natural movement involves lateral movement, but to map that type of absolutely natural movements to a particular type of focused movement in the virtual world may be difficult. So, specialized setup is used to cancel the lateral movements of the user, so that it is easier for the system to understand the user's intention and accordingly perform the navigation in the virtual world. So, what kind of specialized setup used? So, for example, a linear treadmill may be used, motorized floor tiles may be used, human sized hamster ball may be used, or a friction free platform may be used. These are some of the techniques. Of course, there can be other setups possible. Now, using this type of specialized setup, whatever lateral movement takes place can be detected and eliminated before the movement is mapped to the virtual navigation. Now, all these are part of walking based navigation. The second category of navigation is steering based. It indicates continuous control of direction and speed while the user is moving from one point to another. So, whenever there is a continuous control of direction and speed, essentially we can safely assume that the system has implemented steering based navigation. Now, this is also of two types: spatial steering based navigation. In this case, the navigation is controlled using user's body parts, and physical steering based navigation, where the navigation is controlled, the locomotion is controlled using vehicular props or some additional hardware. What is the spatial steering based locomotion technique? So, it can be gauge directed, that is, the travel follows where the user is looking. So, just by looking at a distance, we can move continuously to that target location. So, it follows the direction of looking. Then it can be hand directed. Hand direction determines direction of travel. So, we can provide the direction through hand gestures, and then correspondingly the system maps that hand gestures to travel in a specified direction where the hand is pointing. It can also be body leaning directed. So, we lean the body towards the direction of movement, and then that gets mapped, and then corresponding travel takes place. As opposed to that, where we are using our body parts like gauge, eye or hand or body, whole body, there is a physical steering based locomotion technique category as well, which involves some physical setups, some separate hardware such as bike locomotion platforms, VR simulators for aircrafts, merchant ships, cars, boats, spaceships. These actually come with this type of physical steering as shown in this example. So, this is a bike simulator where you can see the physical steering, and by moving the steering physically you can move the you can perform the travel in the virtual world. Similarly, here you have physical steering props which is used to in this flight simulator here, which is used to perform travel in the virtual world. So, that is about walking based and steering based. The third category is selection based navigation or locomotion technique. Now, it allows users to focus on where to go rather than how to. In the previous techniques, user has to specify by moving the steering or looking at the direction continuously or performing walk for movement. User has to specify how to reach to a destination, whereas in case of selection based, user can focus on where to go, need to select where to go rather than specify how to go there. Now, this locomotion technique category can also be of different types. We can have target selection based locomotion, we can have route planning based locomotion. So, in case of target selection based locomotion, what happens is that the user selects the destination or the target where the user wants to move, and the virtual viewpoint changes, or in other words, it lets the user feel through that change that the user has actually moved to the target. One very common such technique is teleportation, that is instantly moving from current location to the target location. Similarly, on map dragging also, if we fix the location, then we can instantly move there. Another technique is jumper technique in the cave type systems. So, as shown in this animation, small animation, that the user here is selecting the target here, and then immediately the viewpoint gets changed, as if there is an instant travel taking place from the current viewpoint to the destination viewpoint. This is example of teleportation. The next type of technique is route planning. This is also another type of selection based locomotion. However, in this case it is not that only the end is selected. It can provide more granular control over travel, unlike teleportation or target based locomotion, where only the end point is selected and we instantly move there. In case of route planning, what happens is that instead of the target, we select a route that takes us to the target. There may be multiple routes, and user selects a route that takes us to the target, that takes the user to the target in the virtual world, and while moving through that route, different changes in viewpoint is implemented, so that user feels that he or she is moving along a path. So, it is a little bit more natural kind of movement as compared to target based teleportation type movement. So, those are about selection based. The final category of locomotion techniques are manipulation based locomotion techniques. Here the locomotion works by manipulating user's position, orientation or scale using gestures that control either virtual viewpoint or virtual world. Earlier we have talked about the go-go technique, Homer technique, world in miniature, metaphor. So, using a combination of these different manipulation techniques and metaphors, we can implement manipulation based locomotion. Say for example, in a world in miniature metaphor, if we move certain objects, then correspondingly or manipulate certain objects, then corresponding change in viewpoint happens as if the user is moving from one place to another. So, this type of implementation are possible through manipulation based locomotion techniques. Since we have already discussed these techniques before, we are not going to discuss further what is go-go or what is Homer manipulation or what is world in miniature. Please refer to the previous discussions, previous lectures for discussion on these concepts. So, with that we have come to the end of our discussion on locomotion techniques. Now, if you recollect, other component of locomotion is wayfinding, other component of navigation is wayfinding. So, there are two components of navigation, one is locomotion or travel, that is the motor component, and second component is wayfinding. So far we have discussed about the motor component. Now, let us move our attention focus to the wayfinding component. Now, wayfinding refers to many things such as location awareness, where one is located, ascertaining a path through the environment to the desired destination, transferring spatial knowledge to the real world. So, essentially it refers to a mental model. So, the goal of wayfinding is basically to build a mental model or a cognitive map of the surrounding as well as the overall environment, so that it is easier for us to locate ourselves in the environment as well as to identify a suitable path to take us to the destination. Now, our objective should be to design the environment in a way such that it is easier for the user to build such a mental map. If it is missing, if the design does not support creation of this mental map, then lot of problems may happen and that will have a deteriorating effect on the overall user experiences. Now, when we talk of spatial knowledge in that mental model or the cognitive map, what we are referring to is landmark knowledge, procedural knowledge and topological or map like knowledge. So, we should have knowledge about landmarks in my surrounding as well as in other places, some sort of procedural knowledge or the sequence of actions required to follow a path, and overall map of the environment or topological knowledge of the environment. Together they constitute the knowledge base which is required or which is essential part of the overall mental model. Now, how can we create the mental model? Essentially by aiding the user to get the knowledge, to understand the knowledge or to infer the knowledge. So, essentially this can be done by the traditional methods are systematic study of the map of a place, exploration of real space, exploration of a copy of the real space or a model of the real space. Either method or a combination of all may give us the mental model or the cognitive model. Then what is required for the system to provide a good user experience, immersive user experience, some sort of support for wayfinding. Note that it is not sufficient to provide good travel support only. Along with that, we need to provide good wayfinding support, so that the travel supports are effectively used or deployed by the user while performing navigation. So, without a suitable wayfinding support, in a complex environment, irrespective of how many different types of traveling techniques are implemented, user will not be able to perform efficient movement. So, how we can provide the wayfinding support? Say, one way is to have landmarks. These are any obvious, distinct, non-mobile objects that are positioned in a given place. Good landmark can be seen from several locations, so it should be clearly visible from different point of view, different locations. We can also provide support for maps of the space of the place. It can be a copy of the world map. In fact, here the term world refers to the virtual world, not the real world, or it can be a world in miniature. So, for example, here it shows a world in miniature type of wayfinding support, which shows the entire world with the objects located at different points, and it can also show the user's current position and different ways to reach different points, many things. Another way the wayfinding can be supported is through path following, that is, multiple paths through a single space may be denoted by colors, so that user knows that there are different paths to reach to a destination. Breadcrumbs can provide another kind of support. It is essentially the idea is to leave a trail of the path followed by the predecessors. So, leaving a trail of markers which allows the users to know when they have been somewhere before, so that user does not get lost. User knows that this path is explored, so let us move to a different path or different destination to save time and so on. A simple aid can be a compass. Another form of direction indicator can specify directions in both 2D or 3D space. So, accordingly a compass can be designed and placed in the environment. So, there can be different ways to support wayfinding. The most crucial thing is to remember that support for wayfinding is an essential requirement if you are designing a complex virtual environment with lots of objects and different ways to reach to the targets. Without proper wayfinding support, irrespective of the sophistication of the travel support, the user may not be able to deploy them efficiently or effectively. So, that is about wayfinding, and with that we can conclude the discussion on navigation techniques. The third interaction technique is interaction for system control. Now, here the goal is to issuing command to change system state or mode, such as launching an application, changing the system settings, opening a file and so on, most of the regular operations that are associated with using any software. And correspondingly, there are several ways to perform those tasks through interactive methods. Different interaction techniques are there for system control. One can be physical controllers such as buttons, switches. Then we have graphical menus, adapted 2D menus suitable for 3D immersive environment, 1 degree of freedom menus, 3D widgets. Then we can also have voice commands to perform the controls, gesture commands such as mimic gestures, symbolic gestures, sweeping gestures, sign language, speech connected hand gestures, whole body interactions. All sorts of regular interaction modes can be deployed. We can also have tools such as physical tools, virtual tools, tangible interfaces, and we can combine multiple techniques to have multimodal interaction techniques for system control, where we can combine say voice with gestures or other sorts of interactions. So, with that we can conclude this part of the lecture where we have covered the navigation interaction and interaction for system control. So, at the end let us quickly summarize what we have discussed so far. We have learned idea of design, essentially interface and interaction. Then we talked about design guidelines, which can provide a starting point for a designer. Then we talked about interaction techniques typically used in immersive settings, primarily VR, also MR, not very important for AR. There we talked about object interaction comprising of object selection and object manipulation. We also talked about navigation interaction comprising of travel and wayfinding, and finally we briefly touched on interactions for system control, which is more of regular type of interaction with any software. In the next part of the lecture, we are going to talk about design of the Majuli VR tour. What are the elements of design that are specific to the Majuli VR tour and how we arrived at those design ideas. So, I hope you could follow the concepts, topics, and those were interesting to you. So, we will continue our discussion on design in the next part of the lecture as well. So, looking forward to meet you in the next lecture. Goodbye, thank you and happy learning.